Okay, let's talk about exceptions in Python. So Python will raise an exception when something goes wrong in your code. That indicates that an error condition has occurred in the code and it's severe enough that Python can't continue executing the remaining code. You've seen this before. For example, when we were looking at dictionaries, suppose that you have a dictionary and it's got keys of Sally, James, and Beth. Then, when you try to access the value at the key of Tom, you're going to get a key error. That's an exception that happens when you try to get access to something in a dictionary using a key that isn't in the dictionary at that time. So that is a built-in exception. Comes with Python. The error message that we got here includes what's called a stack trace. It tells us where the error originated exactly, including the chain of function calls that led to that point. We'll look at some more stack traces later. But first, let's talk about exactly what are exceptions. Well, an exception is an event that can modify the flow of control through a program. And that's true of any programming language, not just Python. An exception is initiated, the wording we use is thrown or raised, automatically on errors. It's initiated in the code, and optionally, we can catch it. We'll talk about that later too. An exception allows us to jump out of arbitrarily large chunks of code. It's mainly used for error handling, but it can also be useful for other things. So for example, we can use it for event notification. We can raise an exception in the event of a failure. We can use it for special case handling. When a condition rarely occurs, we can raise an exception instead of convoluting our code to handle a special condition in multiple places. Or in really gnarly cases, we can use it for logging. I'll give you an example. So some frameworks like React Native, which is a JavaScript framework for writing mobile apps, they redirect your standard output in asynchronous code so that if you have a print statement in JavaScript, it looks like console.log. That won't show up in your console necessarily. But if you need to print something out to figure out what's going on in your code, you can throw an exception. Unlike standard out, the output from an exception goes to standard error. And that will show up in your console. So you won't lose your exception stack traces the same way that you might lose the output of your print statement. Now, let's talk about the default exception handler. Python provides a default exception handler that terminates your programs when you don't handle exceptions. A few things happen. First, the interpreter prints an error message with the type of exception raised. Second, you get a stack trace, a list of lines of code and function calls that took place immediately prior to an exception. Then, your program is terminated with what's called a fatal error. Fatal error just means that the program stopped. So let's look at an example here. We've got some code here, right? We have a list, 1, 2, 3, that we assign to X. Now, we're going to try to print out the value at the 56th index of our list. Our list isn't that big, so of course, we're going to get an exception. After that, though, we have this line of code, print hello. Now, do you think that this line of code is going to print hello? Let's try it. So when we run the code, we see that we got an index error. But note what we don't see. There's no hello here. That's because our program stopped executing after the exception was thrown. So let's take a look at another example. We have here a dictionary, Sally, James, and Beth, each with their ages. And we're going to try to print some different keys with their ages. When we do that, we get a key error while trying to access Tom. Now, let's take a look at our stack trace here. You can see we got a key error on Tom, and then it tells us all of the function calls that led to this point. First of all, it says this happened in the main method. That's the method that we wrote right here, which calls this value. Second, it happened in a print values method. That's this line right here, pointing to that method. Inside of print values, it says that we tried to use the access dictionary method right here. So this is the line that our problem is coming from. And finally, inside of access dictionary, it says that that line return D with the key of K is where we got our key error. That is, here, this dictionary was passed in right there, and a key, namely this one, was supposed to be accessed right there, and that's where our key error was thrown. Now, it's worth noting here that what is happening as the stack trace indicates is that our exception is bubbling up through several layers of code. It happened here when we called this method, in here when we called this method, in main. None of these three functions handle any of the exceptions that come from the various other functions they call, which is why we ended up at the end still getting the error, even though our exception was raised several methods away from where we actually called it. Now, in this course, when you've seen an exception, your first thought has usually been that there's a problem in your code that you need to fix. And often that's true. But you can also control what happens when an exception is raised. That is, you don't have to allow it to bubble up like the example we just saw. Exceptions can also be caught so that they no longer stop the flow of the program. You can do that in Python with what's called a try except block. Let's look at the syntax of that. So here we have a try method. Inside of the try method, we call some code. If any exceptions are raised as we are calling this code, the flow of execution is going to go into the except block. This block of code runs if and only if an exception is raised inside of the try block. So you can see that if we have a dictionary with a key of the rain, and then we try to run it, nothing gets printed out from the except block because no exception was thrown. But if we try to print out the value of a key that doesn't appear in this dictionary, the except block will run. We see that indicated by the fact that this print statement happened. It's worth noting that after the except statement runs, or rather after the try statement runs, whether or not the except statement run, code execution will continue after the try and except block. So regardless of whether an exception is raised in the try block or not, this code after the try except block will run. Now, we've seen except, which will catch any exception, but you can also specify the type of exception that you want to handle, and you can handle different exceptions in different ways. We know that when we tried to access a key in our dictionary that wasn't there, we got a key error. And so we can be more explicit in the type of exception that we're accepting. But this is especially useful if your code might throw different errors, and you want to handle each of those different kind of errors differently. Let's look at an example, a function called retrieve that takes in a collection and accesses the value in that collection at a given index. Now we know that with a list, you can access a value at an index of an integer. And with a dictionary, you can access a value using a key of any hashable type. So retrieve can take in a couple of different types, but those different types throw different kinds of exceptions when the thing that you've asked for isn't there. Suppose we try to retrieve from a list at an index that isn't there. That's going to throw an index error. By contrast, if we try to access something from a dictionary with a key that isn't there, we get a key error. Let's try running our function and see what happens. The first time we tried to run it, when we tried to access an inaccessible value in a list, we got an index error exception. The second time, when we tried to access something that was inside of a dictionary, we got a key error exception. Finally, we tried to access something from an integer at the what index. Now, you can't get stuff out of an integer like this, so we would have gotten a completely different exception from an index error or key error. That dropped into our catch-all exception case, which doesn't list a type of error, but rather just picks up anything else that has not already been caught. And that prints, wow, what did you do this time? It's also worth noting that you can get a hold of an exception itself in the catch block. So you don't necessarily just lose the exception. You can access it by saying except exception as E. This can be helpful because then you can print out what the exception is to figure out what's going on to debug your code. Let's look at the same retrieve examples that we were looking at before, but this time with this code that catches the exception and then prints it out. You can see now that we're getting a message related to each of the types of exceptions that were thrown. An index error gives us the message, list index out of range. A key error gives us the message of the key that it tried to access that was missing. And then the last exception that we got says int object is not subscriptable. This is an exception indicating that an integer type doesn't have any kind of method on it that allows you to do this bracket syntax with it. It's called subscripting. As you can see, different types of errors print differently. You can specify how an object prints. We'll learn about that later though. So, some exceptions are hard to check beforehand, especially I/O errors, errors having to do with input and output. If an exception type isn't caught, then it's going to keep on propagating, generally producing the default error message with a stack trace. Let's look at an example. We have a method here that will divide one input by another. Suppose that we try to divide by 0, we're going to get a 0 division error. Now, suppose that we try to divide 5 by foo. That's not even 0 division. That just doesn't make any sense. And when we try to run this, since 0 division error is not the type of exception that was raised, it isn't caught because we have no catch-all except block here. So instead, the error just bubbles up and we see unsupported operand types for divided by, int and string. Technically what this means is that the integer type doesn't have the divide method on it, which takes in a string as an argument. The type error happens inside a try except block, but we're not catching that error specifically, which is why the error bubbled up. Note also that a try except block will catch exceptions that originate in function calls, so the exception doesn't have to be raised by code directly contained inside of the try except. Instead, we can raise an exception on this code that happened out here, outside of the try block itself, defined outside of the try block itself. Note also that once an exception occurs, no other code is run after the line that causes the exception. There's one more important thing to know about using exceptions. The try except block also has a finally clause that gets run whenever you finish going all the way through a try except block, whether an exception is raised or not. So it works similarly to what we saw up here, where this print runs regardless of what happens in this try and except block. Okay, so that's useful when there are any cleanup operations that need to be performed. An example might be closing a file or closing a database connection. Suppose that you opened a connection to a database, or you opened a file and you tried to run some operations on it, then got an exception. It would be a bad thing if the code terminated and you just didn't close that file or didn't close that connection to the database. That could result in more and bigger problems later down the line. So to handle a situation like that, generally what we will do is we will define a finally block. We'll try to do some code. Let's say we try to do some stuff to an open file, to an open database connection. If it doesn't work, we try catching the exceptions or even bubbling them up. And after that happens, we run a finally block that would close that database connection or that file. You can think of try as opening a box that might have something dangerous in it. You can think of except as having some reinforcements on hand to help you handle the potential dangers in the box. And you can think of finally as your operation for closing the box at the end of your escapades. No matter what, if the finally block is there, then the box will be closed. This allows you for quick cleanup, even if something messy happened inside the box. Let's look at our safe divide function to see what happens as we try to divide different things. We divide 6 by 2, we end up with, hold on, let me run this line of code. We divide 6 by 2, we get that x is 3.0. They tell us that divide was called with 6 and 2. This print statement happens inside of the finally block. Now in this case, an exception wasn't thrown, but the finally block still ran. Now when we try to divide 6 by 0, we'll get a 0 division exception. But still, the code in the finally block runs. Now let's try dividing 6 by foo again. Once again, we get an exception that we catch. And once again, the finally block runs. So we've talked about catching exceptions. You can also raise exceptions. That is, you can explicitly initiate an exception occurring on purpose in your own code. You can catch your own raised exceptions by using a try except statement in the same way that you would catch an exception raised by the interpreter. It's worth noting, though, that only instances of an exception class can be raised, or an exception class itself. It's also possible to re-raise an exception in the except clause. Let's talk about what all these things mean. We have a class of person here, which we are going to initialize, right? And what we want to do is we want to check the type on some of the things we're passing in. We want to make sure, namely, that the name is a string and that the age is an integer that's greater than 0. Now, those things wouldn't raise exceptions on their own because Python is dynamically typed. So we wouldn't find out that one of those items was the wrong type until we tried to call a method on it that attribute didn't have because of its type. So in order to prevent that, what we've done here is we've manually raised a value error. We raise a value error for the name needing to be a string. Then we check if age is an instance of integer, and we raise a value error if it isn't. Then we check if age is greater than or equal to 0, and we raise a value error if the age is not greater than 0. If all of those checks pass, then we assign the attributes that we use to initialize the person to the attributes on the instance. Let's try this. We're going to try to create a person named Sally, age 45. We see that it works because Sally and 45 are both of the appropriate type. Now, let's try to pass in a list with Sally's name in it instead of a string. This is going to tell us that name must be a string because our value error got raised. Now, suppose we try to make Sally -1 years old. That's not going to work because when we check that her age is greater than 0, a value error again gets raised. Finally, if we try to pass in a string for Sally's age, we'll see our other exception, that age must be an integer. Now, Python comes with a number of built-in exceptions that we can use and co-opt as we want to. Here's the full hierarchy, but you can also read in the Python documentation about all of the different exceptions that are available to you. You can read about when it might be appropriate to use them and when you can expect to get them from the interpreter itself. But suppose none of that's good enough for you. Suppose you want to write your own exceptions. Well, it turns out you can do that. Let's write one. In keeping with our favorite theme, let's call it an Angry Bird exception. So here's our Angry Bird exception, and you can see that it inherits from exception. Now here's what we're going to do with that Angry Bird exception. We have got a parrot. Now as we all know, if you bother a parrot too many times, parrot gets mad at you and tries to bite you. So that's what we're going to do here. We have our parrot, we initialize our parrot, and then if we try to interact with the parrot, if the parrot is angry, we're going to raise our own custom Angry Bird exception. I'm passing in a message to the Angry Bird exception for it to print out. That's it, bucko. You're getting the beak. Okay? If the bird's not angry, then it gives a warning. Careful, I might bite you. So, we've got a couple of different birds that we're going to try our custom exception on. The first one is Calm Cockatoo, and he's not angry. And then we've got our Raging Ringneck, and that bird is angry. Let's try making eye contact with them both. Now, the first one, the Calm Cockatoo, says, careful, I might bite you. But then when we try to make eye contact with the Raging Ringneck, we get an Angry Bird exception. Here it is, Angry Bird exception, with the message, that's it, bucko, you're getting the beak. We also get a stack trace here. We see where our exception was raised. It's in this method, which was called from parrot, which was called in make eye contact with, which was called here with Raging Ringneck. So we can see exactly where our problem came from. There is one more thing I want to mention about that, which is that in our Angry Bird exception, we didn't do anything, we just passed and inherited from a regular exception. But you can add custom behavior to an exception just like you can to any other class. So in the next example, instead of passing a message in at the point where we instantiate the Angry Bird exception, we'll include the parrot's anger as a custom message on the exception itself. And we don't have to pass it into the exception's initializer anymore. So now our Angry Bird exception automatically initializes with a message of, that's it, bucko, you're getting the beak. Now, when we implement our parrot class, we no longer have to pass that message in. We just say, raise Angry Bird exception with no arguments, and our Raging Ringneck knows exactly what to do when somebody makes eye contact with him.